Hello students, moving ahead with the instruction set of 8085 microprocessor. So in this lecture I am going to discuss about the next instruction, that is LHLD address. In the last video lecture I discussed about SHLD address. What does this instruction do? SHLD address, it used to store the content of HL register pair to the address mentioned in the instruction. And LHLD address that I am going to discuss now is just the opposite of SHLD address. So what LHLD address do? It is just the opposite. It will store the content of address to the HL register pair. For example, LHLD, let the address be C000H. So let us suppose at the time of execution of the instruction, let us suppose C000H memory location has the content 20H, and C001, that is address next to C000H, C001H address will store, C001H has the content 30H. So after execution of this instruction, what will happen? Since LHLD C000H is mentioned, that is address C000H is mentioned here. So what will happen after execution of this instruction? The content of the address C000H will get stored in the L register. So L will get stored with 20H. And the content of the memory location next to the memory location mentioned in the instruction, so the next address will be C001H. So the content of this address will get stored in the H register. So H will get stored with 30H. So what does this instruction do? It will store the content of the address in the L register and will store the content of the address next to the address mentioned in the instruction to the H register. So again, flags affected, since no arithmetic or logical operations are involved in this instruction. So flags affected will be no flags will get affected. Number of bytes, again LHLD C000H, let us suppose this is the address. So how many bytes of instruction are there? Apart from the instruction, the extra hexadecimal numbers that are mentioned in the instruction are of 16 bits. So the all total the bytes of the instruction will be 3 bytes, 1 byte for opcode and 2 bytes for the address mentioned. Next, how many machine cycles are used for the execution of this instruction? Now let us suppose, again I am taking an example. Let us suppose this is a memory location, and let us suppose the starting address of the memory location, let it be C0 or let it be 8000H. Now when you're giving this instruction LHLD C000H or LHLD address, whatever you write, whatever address you mention, so when you're giving this instruction will get stored in the memory that is associated with the microprocessor. And how it will get stored? First the opcode of the instruction will get stored, the next memory location will store the lower byte of the address, and the next memory location will store the higher byte of the address. So what will happen at the time of execution of this instruction? First opcode of this instruction will be fetched by the microprocessor. So microprocessor will fetch the opcode. So first machine cycle for opcode fetch machine cycle. So first is opcode fetch machine cycle. Now after fetching the opcode and decoding it, microprocessor will get to know that it has to store certain content into the HL register pair, and that content is present in the address which is present in the memory. So the next machine cycles will be used by microprocessor to fetch the address of that memory where the content is stored. So the second machine cycle that is will be used by microprocessor is memory read machine cycle for reading the lower byte of the address, and the third machine cycle will be used by microprocessor for reading the higher byte of the address. So all total, now up to this point, 3 machine cycles has been used and the address has come to the microprocessor. So now the microprocessor is having the address. Now fourth machine cycle will be used, since it has to, since this instruction means it will store the content of the memory locations in the HL register pair, and the address is now present with the microprocessor after 3 machine cycles. So the fourth machine cycle will be used by microprocessor for reading the content of the address, that is C000H. So fourth machine cycle is also memory read machine cycle for reading the content of C000H and storing it into the L register. And the fifth machine cycle will also be used as memory read for reading the content of the memory location, next memory location, that is C001H here, and to store it in the H register. So all total 5 machine cycles will be used for the complete execution of this instruction. Now how many T states? Since there are 5 machine cycles, and first machine cycle is opcode fetch machine cycle, which is having 4 T states, and the second machine cycle and the rest of the machine cycles are memory read machine cycles. So 4 memory read machine cycles, each memory read machine cycle will be requiring 3 T states. So all total how many T states? 16 T states. Next, addressing mode. Since the operand's address is directly mentioned in the instruction, as it is LHLD address, so the operand's address is directly mentioned in the instruction, so this instruction will have direct addressing mode. So here I have written also direct addressing mode. Now the next instruction that I am going to discuss is STAXRP. So what does this instruction do? So the next instruction is STAXRP. So let us suppose it is, let me write it like this: STAXRP is representing register pair. You can write any register pair, whether it be BC or whether it be DE or whether it is HL. Any register pair of 8085 microprocessor you can write, and while mentioning the register pair, you will always write the higher higher byte register of the register pair. For example, in case of BC register pair, you will mention B. So for example, STAXB. Or if it is HL register pair, so you will write STAXH. So higher byte of the register pair you will mention. Now what does this instruction do? Suppose, let us suppose the content of the let us suppose the STAXB, let me take STAXB, and let us suppose the content of BC register pair is 6030H. So what it will do, and let the content of accumulator be, let it be 20H at the time of execution of this instruction. So after execution of this instruction, what will happen? The content of accumulator will get stored in the memory location whose address is specified by the register pair. So here what will happen? Here the accumulator content is 20H and the memory location whose address is 6030H, that is whose memory the memory location whose address is actual the content of BC register pair. So what is the content of BC register pair? Here it is 6030H. So that memory location whose address is 6030H, the content of accumulator will get stored in that memory location after execution of this instruction. So again I am repeating, what does STAXRP do? It will store the content of accumulator into the memory location whose address is specified by the register pair. So here So here what will happen, flags affected, again that is a data transfer group instruction. Again it is a data transfer group instruction. So flags affected will be no flags will get affected. And number of bytes of the instruction, as you can see, stax rp, since there is no hexadecimal, extra hexadecimal number mentioned in the instruction, so the bytes of this instruction will be 1 byte only, that is the opcode of the instruction. And since there is no extra hexadecimal number mentioned in the instruction, so the number of bytes is 1. Now how many machine cycles is needed for the execution of this instruction? For execution of this instruction, obviously first what will happen, how this instruction will get stored in the memory location. Since it is of 1 byte, that is opcode, only the opcode will get stored in the memory location. And at the time of execution, when microprocessor is going to execute this instruction, what it will do, first machine cycle will be used for fetching the opcode. That is for fetching. After fetching the opcode and decoding it, microprocessor will get to know that it has to store the content of accumulated into a certain address. That address is also present with the microprocessor because it is the content of the register pair which is present in the microprocessor. So first machine cycle for opcode fetch and decoding it. So after decoding it, second machine cycle will be used, that is for memory write, and that is for writing the content of the accumulator into the address. That is for writing the content of the memory location into the address. That is present in the register pair mentioned in the instruction. So all total 2 machine cycles will be used. Now T states, how many T states will be used? Since this STAX RP instruction involves 2 machine cycles, one for opcode fetch and another machine cycle for memory write, and opcode fetch machine cycle has 4 T states and memory write has 3 T states. So all total 7 T states will be used for complete execution of this instruction. Now what is the addressing mode of this instruction? Since STAX RP, what is happening, whenever I've already discussed that whenever the address of the operand is indirectly mentioned in the instruction, then that type of instruction will have registered indirect addressing mode. As you can see, STAX RP, or you can say for example STAXB, here the address of the operand, that is operand, which is the operand? What is the operand here? It is either the content of the accumulator or the content of the memory location represented by this register pair. So what is happening, the operand's address is indirectly specified by the register pair. So this type of instruction will have register indirect addressing mode. So I'm ending this class here. Will continue with the with other instructions in the next lecture.